Okay, in this video we are talking about drawing magnetic fields. So let's dive right in. Here is the field around a bar magnet. And we can extract some of our rules for drawing these kind of field diagrams. Firstly, you may notice in my diagram that field lines do not cross. Secondly, the direction of these arrows is from north to south. That's why I have arrows pointing in towards my south pole and out away from my north pole. Okay, and the final thing to know is how close those lines are together tells me about the strength of my magnet. The closer the lines, the stronger the field. You should be able to see here that for my bar magnet, the field is strongest at the poles. Now let's look at some special cases of magnetic fields. What does the field look like between a north and a south pole? Straight, parallel, evenly spaced lines. We call this field a uniform field because it is the same no matter where you are within that field. Okay, now let's see what the entire field here looks like around and between these two bar magnets. This new pattern comes from the individual patterns of my two bar magnets adding together. What happens if I have two like poles facing each other? Again, you have two magnetic fields interacting with each other, and so you get this shape here. Again, note the direction of my arrows, always away from the North Pole and towards the south. And what if I put two south poles facing each other? Well, I'd get the same picture, but my arrows would be the other way round. So how do I find these patterns? Well, I'll show you. It involves an A3 piece of paper, a bar magnet, trigger warning for those of you on DOV, it does involve a compass, and a lot of free time and patience. Okay, so take your magnet and put it in the centre of your paper. Draw around your magnet with a pencil. Okay, then grab your compass and put it somewhere near the magnet's poles. Okay, and you should see that that compass has moved and it's pointing in a particular direction. So mark a little dot where your compass is pointing, and then move your compass to that dot. Okay, now the needle may have changed direction slightly, so mark a new dot, and then move the compass to that dot. Okay, and then continue the process until your compass has either come back towards the magnet or is off the piece of paper. Take your compass away, join those dots together. Then complete the process, moving your compass to a different initial starting point. Okay, eventually you should have a pattern that looks a little something like this. Remember, your arrows should be pointing from north to south. So if I wanted to add arrows to my diagram, then my finished picture should look a little something like this. The reason I was able to draw that picture is because the arrowhead of the needle in the compass is attracted to south poles. We know if we move a compass away from other magnetic fields around us, that the arrow should point to my geographical north pole of my Earth. That must mean that it's as if at my geographical north pole, there is a magnetic south pole from my Earth. And that is exactly right. The Earth has its own magnetic field associated with it. And that's how my compass always points north. Be careful when you're using a compass to find the geographical north, that you're not near any other magnetic fields. Okay, thanks for watching. Make sure you download the notes, those field line rules and all of the relevant patterns. If you like the video, please do give it a like and subscribe. Thanks for watching.